Welcome to innovatehub.wordpress.com. I'll be starting with the GATE series here. We'll solve previous year papers and we'll learn some new concepts. So first question that we are solving is from GATE 2014 CS paper, and it is from mathematical logic. It is saying, consider the statement, not all that glitters is gold. Predicate glitter x is true if x glitters, and predicate gold x is true if x is gold. Which one of the following logical formula represents the above statement? So there is a statement given and we have to represent it in the form of mathematical statements, which is given below. And one of these statements exactly means, make sure it exactly means this statement. Okay, so before we learn these, we have two concepts that we must understand. They are universal quantifier and existential quantifier. So whenever we come across this symbol, it's kind of a reversed A. So this symbol means for all. Okay, and whenever we come across this symbol, it means there exist. Okay, so we have to represent a statement in the form of these two quantifier symbols. So universal quantifier, what do you mean by universal quantifier? That means it needs to be true for everything, for all, for everything. Sorry. So it needs to be true for everything, for all, for any value that comes. So whenever we say for this symbol and x, it means that x can take any value in the universe, and that should mean for all. And when we say existential, there could be any one of those and it will suffice. Then it not be true for more than one, it may be true for only one, then also it will supply, but it cannot be true for zero. There should be at least one. So there are two predicates in the given statements. We have to find out the predicates first, even if this statement is not given, that is the predicate glitter x is gold and gold x is true. We can assume that predicates. So these are the two predicates that we have fetched. One is saying that it is glittering. The other one is saying that it is gold. And the complete statement is saying not all that glitters is gold. So I'll just represent them in these two form. So one says that x such that x glitters and such that x is gold. These are the two statements that I have represented. What does these means? These means that x can take some value, whichever comes in this domain, it will be true if it glitters. So if I saw something, say I saw something which was shining from far away, and I said, yes, this is gold. But one of my friend came and saw me, and he saw me seeing that shiny thing. He said, no, my friend, not all that glitters is gold. So what is he trying to say? He is trying to say that I think that shining thing is gold, but it might not be true. Why? Because not all that glitters is gold. So something which might glitter might not be gold. Okay, that's what he's trying to say. So how are we going to represent? So, but this statement is different from saying we cannot assume that gold glitters. We cannot assume. So here's a catch. So I know this is confusing, but this at the first time, and this needs to be cleared. So even though the statement says not all that glitters is gold, it only says this much. It does not mean that every gold glitters. We cannot assume that. So we are trying to say, or we are not trying to you know, infer something from this statement. We're just trying to represent the statement exact what it is. So I'll just try and tell you what are these four statement means in English, and we'll just erase this. So the first statement says this symbol. What is this symbol? Universal quantifier. What was that? For all. So I'll just speak. So how do we say it? For all x. So that means you take any value of x such that, now this arrow and there is this symbol. Actually this is not this symbol. This is not U. This is sort of a V. And this one is sort of an A. So what is this? This is or. This is and. And this third one, this is not. Okay. So this one is basically or. Okay, not and. This is wrong given. Okay. So and this one is negative of x. But there's another one which is arrow. What does this arrow means? So whenever we say P, arrow, Q, I'm sure you must have come across this. If you have not, so you will come across now. So it's saying, what does this arrow means? This arrow means if, then. And yes, it literally means this. In first order logic, we're more on the meaning of the sentence and not on the on the logic. So it's more on the meaning of the sentence, okay? So just like this statement logically means that all gold glitters, but we're trying to get the meaning, we're not trying to get the logic. So this statement, this is arrow means if then. So how will I say this one? For all x, if x is glitters, or if x glitters from this function, same function, then gold is not true, or we can say then it is not gold. So if x glitters, then it is not gold. So let's just go back to our statement and try and get it. We were saying not all that glitters is gold. Does this statement means this? No, because this statement says not all that glitters is stale. So it is trying to say that gold, there is something glittering and it might not be gold. It is not saying anything else. So if X is glittering, it might not be gold. It's not saying for certain it is not gold. So, but if and then says for certain it is not gold. So this is not the right answer. Second one says for, so I'm not going to write this again, I'm just going to say it. For all x, that means for any value of x, if x is gold, because there is an arrow symbol, then x glitters. So yes, logically we are coming across this same statement. Had it been a logic uh, kind of a statement, this would have been true. But we're not going for the logic, we are going for the meaning of the sentence. But what does this meaning says? Meaning says that I saw something shiny and it might not be gold. So let's see if this means, we'll put this on hold. Okay. So this one says there exist, I told you this is an existential quantifier. There exists x which is gold and it does not glitters. So actually it is not trying to say this, right? We can clearly say this no. But even if you're confused, I'll just say, so it is saying not all that glitters is gold. So something which is something kind of glittering, but it might not be gold. Okay, might not be gold. I hope this one is clear, right? So this one is saying if it is gold, sorry, this one is or means either it is gold or it is not glittering. Clearly this is not what it is trying to say, right? So just a second. So this one is wrong. Last one says, please ignore this symbol. So this one says there exists X such that either it does not glitters, either it glitters or it is not gold. So it is trying to say there exists something which glitters and it is not gold. So this symbol is actually, I've written the typing error is there. So this has to be and. So that's why the fourth point will be right. And why we cannot say second one right? Why we cannot say second is the correct answer? Because second is not exactly what it means. Second is something which you have logically inferred. It does not exactly mean the same thing. Whereas the fourth one exactly means the same thing. Not all that glitters is gold. There exists something which is not gold, and that is what the answer is. I hope I have made these two concepts clear, which is of the universal and existential quantifier. We'll be solving more problems and you can clear the concept. In case you have further doubt, please mail it to me on innovatehub.wordpress.com. Please like, comment and share this video. Thank you.